Next, coming into one of the most important topic, linear programming. So linear programming is a mathematical method used to get best outcome. What is best outcome? When it comes to profits, we will maximize profits. When it comes to cost, time, distance, we will minimize it. So linear programming is also a which one? Optimization model. What optimization model will do? It will maximize the profits or minimize the cost. It will consume the least amount of resources to get maximum benefit. It helps us to decide how to use resources like time, money, material, labor in best way. So nothing but it will utilize least resources to get maximum or best output or best amount of benefit. Example, imagine you run a small bakery. You can make cakes and cookies, but you have only 8 hours a day and 10 kgs flour. Now you want to maximize your profit, but you can't make unlimited cakes and cookies because of time and flour. Let assume I am bakery owner. I want to bake both cookies and cakes. Now I have how much of time? 8 hours and 10 kgs of flour. So within this limited resources, I want to maximize my profit. Can I make unlimited cookies and cakes? Why? Why? Because limited resources. Now, linear programming will do how many cakes I should produce, how many cookies I should produce so that my profit will be at maximum. So, by solving the linear programming equation, I may arrive that how many cakes and cookies I must produce to get maximum amount of profit. Now, I will give you one example where we use this linear programming. Let assume there are two products A, B. Selling price is 100 rupees. For B, it is 80 rupees. Now, variable cost. So it consists of both labor as well as direct material. 60 and 50. Now, direct material. A requires 2 kgs, B require 3 kgs. Direct labor. A require 4 hours, B require 2 hours. This is the problem. Now, case 1. Direct material is limited. Case 2. Direct labor is limited. In a company, there are two products, A and B. The selling price is 100 for A and 80 for B. The variable cost is 60 and 50 for A and B. A consume 2 kgs of raw material, B consume 3 kgs of raw material. Direct labor. A require 4 hours, B require 2 hours. Now, case 1, direct material is limited. If direct material is limited, which product you will produce first? If direct material is limited, which product you will produce first? See here, contribution is how much? 40, 30. For 1 unit, you are getting how much? 40 rupees as a contribution. For 1 unit, you are consuming how many kgs? 2 kgs. That means for 40 rupees, you are consuming 2 kgs. By consuming 2 kgs of raw material, you are getting how much? 40 rupees. That means per kg you are getting how much? 20. Yes or no? Here it is 20. That's it. Yes or no? Am I clear? Next. For B, contribution is how much? 30 rupees and you are consuming 3 kgs of raw material. That means by consuming 3 kgs of raw material, you are getting how much? 30 rupees. Per kg it is 10 rupees. If raw material is limited, if you consume this particular raw material for purpose of producing A, you will get 20 rupees per kg. If you consume that particular raw material for producing B, you will get 10 rupees per kg as contribution. For example, raw material is limited to 100. Raw material is limited to 100. Then if you consume this particular raw material for A, you will get 20 rupees per kg into how many kgs we have? 100 kgs. That means total you will get 2000. Am I clear? Next, you have how many kgs of raw material? 100 kgs. If you consume this 100 kgs for the purpose of B, you will get 10 rupees per kg into 100, that is 1000. So which product do you produce now? A or B? A. Why? Because the contribution per kg of raw material is high. Next, now raw material is not limited, but which is limited, Nana? Direct labor is limited. Raw material is unlimited and direct labor is limited. Now, what is the contribution? 40. And what is the hours required to produce product A? 1 unit of product A require how many hours? 4 hours. You are getting 40 rupees for how many hours? 4 hours. That means per hour you are getting how much? 10. Here you are getting 30 rupees for how many hours? 2 hours. That means 15. Now, for example, you have only 50 hours. How many hours? 50 hours of labor. If you produce product A, in this 50 hours, you will get per hour how much? 10 rupees. 10 rupees into 50 hours how much? 500. Next, if you produce product B in this 50 hours, you will get how much? 15 rupees per hour. 50 into 15, 750. So you will go with which product? Product B. Why? Because the contribution per labor hour is high. Now tell me, now direct material is limited as well as direct labor is also limited. Direct material is 100 kgs we have and direct labor is 50 kgs we have. Now which product you will produce and how many units you will produce? Till now we solved the problem using which techniques? Marginal costing techniques, and that too key factor analysis. By using key factor analysis in marginal costing, we solved till now. Now my question is, now both direct material as well as direct labor are limited. Which product do you produce now? You can't say directly. By using marginal costing techniques, you can't solve it. For this type of problems, we use linear programming. Whenever we have single limited factor in the problem, we use marginal costing technique to solve the problem. When we have multiple limited factors, more than 2 or more limited factors, we use linear programming techniques. By using one mathematical equation, after solving mathematical equation through graphical presentation method, or simplex method. For solving linear programming problem, we have two methods. One is graphical presentation method, another one is simplex method. We solve the problem and we will get the answer. Did you understand? Am I clear? For single limited factor, we use marginal costing techniques. For multiple limited factors, we use linear programming. So for to solve this type of complex problems, we use linear programming. Next, for this type of problem, we use linear programming. What linear programming will do? Linear programming help you decide how many cakes and cookies to make to get most profit. Now, linear programming help us to how many cakes that we need to bake to get best profit or maximize our profit. Now, where we use linear programming in production scheduling. A textile factory want to plan how much cloth to produce daily with limited machines and workers to meet future orders. One textile industry is want to know that how many meters of cloth it should produce to meet the future demand with limited resources like limited mission hours as well as limited labor hours. Now, linear programming will solve this problem. Distribution problems. A food company need to decide how much bread to send to each city to save transportation and meeting demand. Now, one of the transportation company want to know how much amount of goods it should transfer to each city to get minimum transportation cost. Next, investment decisions. For example, I have 10 lakhs. I want to invest in one of the best portfolio. What is portfolio? Group of stocks. Not only stocks, debentures, government bonds, uh, commodities, futures, like that. Now I have 10 lakhs. I want to invest in best portfolio. My objective is to get maximum return with minimum risk. Now linear programming will solve this problem. So how much amount I should invest in this particular shares? How much amount I will invest in this particular debentures? How much amount I have to invest in this particular which one? Government bonds. Next, commodities, futures. It will give me one picture data. If you invest, if you go with this particular portfolio, you will get this much amount of return and this much amount of risk. That is my maximum return and minimum risk. Next, advertising mix. I have 1 lakh. I want to advertise my channel. What is our channel? CA, CMA Simplify. I want to advertise my channel with an amount of how much? 1 lakh. Now I have 3-4 options. I may go with YouTube. I may go with Insta and TV as well as radio. Now, how many advertisement I need to give in TV? How many advertisement I need to give in Instagram? How many advertisement I need to give in this YouTube channel to get maximum reach? Why I am giving my advertisement? To get more subscribers as well as to get more reach of my channel. That's it na. That is my objective na. Now for fulfilling my objective, how many advertisements I need to give in this particular TV channel? How many advertisement I need to give in Instagram to get maximum reach? Linear programming will solve my problem. Next, CVP analysis. What is CVP analysis? You know, are you done with your marginal costing? Yes or no? The first chapter itself it is CVP analysis. Without knowing the first topic, you know sales, you know contribution, you know variable cost, but you don't know the topic name. You know all things, you know break even point, you know indifference point, you know all ingredients, you mixed it, but you don't know the delicious food you cook. By mixing some ingredients, you cooked one food. That food is very delicious, but you don't know the name. The first topic what you learned in the marginal costing itself, it is a CVP analysis. You don't know the name. You already completed with your marginal costing. Very good. Next, trim problems. A paper company want to cut large sheets into smaller ones without wasting any paper. In paper industry, the sheets are very large. Now that paper industry want to cut the sheets into small pieces, small papers without incurring high amount of loss. It want to reduce its waste. It is also nothing but minimizing the wastage. Now our linear programming will solve this problem. Other easy to relate applications, work scheduling. Hotel manager uses LP to schedule shifts with minimum workers by 24/7 service. What hotel manager will do with minimum amount of workers? He will run the hotel for 24/7. He will allot the time slots to each and every worker to entire 24/7 time. Next, joint product. A dairy makes butter and cheese from the milk. LP tells how much of each to make to earn more. One dairy is there, Heritage. It is making two products, butter and cheese, by using milk. Now this Heritage will do how much amount of milk I should use for making cheese, how much amount of milk I should use for making butter, to get maximum profit and minimum use of milk. What is our resource? Milk only, na? What is our raw material? Milk. With limited usage of milk, I have to produce maximum amount of cheese and butter to get maximum profit. Next, scarce resources. You have 500 as well as limited time. LP help us to decide which product to buy to resell and earn more profit. With an amount of 500, you should buy one particular product, and you will sell that particular product in the market to get maximum profit within the limited time. Next, petroleum mix, nothing but product mix. What is the substance for petroleum? What is the input for petroleum? Crude oil. What is the input for diesel? What is the input for gas? Kerosene? Crude oil. Yes or no? So these all products are coming from crude oil only. Now petroleum company will decide how much crude oil I should use for producing petroleum. How much amount of petroleum I should take from that particular crude oil, and how much amount of diesel I may take from that particular crude oil. This is nothing but product mix. So LP is used in every industry, financial industry, manufacturing industry, service industry, next to sugarcane. In all industries, LP will be used. Why? Because every company want to make more profits. Every company want to reduce its cost by using less amount of resources, scarce resources. it has to get maximum profit. What is the format of linear programming? Maximize or minimize. If your objective is maximization, what you will maximize? What things you will maximize? Profits, sales revenues, sales units. You will maximize these all things. If your problem is given in the terms of or given data like that, you have to maximize your profit, you have to maximize your sales, you have to maximize your sales revenue, then your objective will be maximize. Or the data of the problem given like cost, distance, next time, your objective will be minimize z. Now for example, it is profit. How to maximize profit? What profit? You are maximizing single product profit, or you are maximizing entire company profit. Here you are maximizing entire company profit. How to get a entire company profit? Profit of product A plus profit of product B plus profit of product C. You will add this all profits, you will get the profit of company. This is the profit of product A, this is the profit of product B. Like that, if you add the all profits of all products, you will get the entire profit of product, or sorry, company. So this is our objective function. What is our objective? Either to maximize profit or minimize cost. Now subjective constraints. So what is this constraints? Your limited factors. Like if you see, already we discussed that bakery example. What is our limited resources there? We have only 10 kgs of flour and 8 hours of time. That is our limited resources. You can make n number of cakes, you can make n number of cookies, but within the time of 8 hours and within the raw material of 10 kgs of flour. You can make how many products you want, cakes or cookies, but within 8 hours of time and within 10 kgs of flour. Yes or no? And our objective is to maximize our profit. Now simple, what is that? Profit or cost? What we want to maximize or minimize? If you want to maximize, it will be profit or sales or sales revenue. If it is cost, you will minimize. X1, X2 decision variables, what we want to find, that is our answer. X1 and X2 is the answer. If you find the values of X1 and X2, the answer is completed. Next, what is X1, X2? How many cakes and cookies you need to manufacture? What is C1, C2? Profit per unit. That means if you bake one cake, if you bake one cake and sell it, how much amount you will get? How much profit you will get? That is the C1. If you bake and sell the cookie, how much amount you will get for each cookie? That is the C2. A1 and A2. Resources usage per unit. Resources usage per unit. B1 and B2. Total resources available like time, money, raw materials. So how much amount of time we have? 8 hours. How much amount of raw materials we have? 10 kgs. That is the floor na. Now let assume profit per cake is 20 and profit per cookie is 10. If you sell one cake, you will get how much amount of profit? 20. If you sell one cookie, how much amount of profit you will get? 10 rupees. Why you guys are promoting 5-star? You are promoting na. You are doing advertisement for 5-star. Eat 5-star, do nothing. Arey, say something na. You have to respond. Do one thing. While coming from home, take one piece of rock in your bag. Keep it here, you go outside. I am not finding any difference between you and rock. You guys are sitting like a rocks and staring at me like I am a villain. By selling one cake, you will get 20. By selling one cookie, you will get 10 rupees. Now, what is our objective? Here, the data is given in profit. The data is given as profits. Now, our objective is to maximize. What you will maximize? Profits of each product. You will maximize profit of cake, or you will maximize profit of cookie. No, you will maximize the profit of bakery. You can produce how many units you want for cakes or cookies, but ultimately your aim is to maximize the profit of bakery. Now, max z. What is max z? That is maximum profit of bakery. How to get profit of bakery? Profit of cake. Profit of cake plus profit of cookie. Profit of cake and profit of cookie. How to get profit of cake? You know one thing. By selling one unit of cake, you will get 20 rupees. 20 into number of units. You don't know number of units. That is what we need to find. Number of units of cakes and cookies we need to find. So let's take it as x1. Now let x1 is equals to number of units of cake. Let x2 is equals to number of units of cookie. So to get profit of bakery, we have to add profit of cake plus profit of cookie. Total profit of cake and total profit of cookie. You know that by selling one unit of cake, you will get how much? 20 rupees into number of units. 20 rupees. For example, after solving the entire problem, you got 10 units. 10 into 20, that is 200. I am hearing some noise from boys. I don't know much nonsense words in English. If I say something, you will feel. I don't know the meaning of that particular word. Next, profit of cookie is how much? Profit of cookie is 10 rupees. By selling one unit of cookie, you will get 10 rupees. To get entire profit from the cookies, how to get? Number of units of cookies produced into 10 rupees. You will get the entire amount of profit from selling cookies. That is 10 into x, that is our profit. So if you get the values of x1, x2, you will get the total profit of bakery. That is, this is our objective with some constraints. Subjective, subjective constraints. Now, how much time we have? We have only 8 hours. Yes or no? You can produce how many units of cakes you want. You can produce how many units of cookies you want, but within the time of 8 hours. You can't exceed the time limit more than 8 hours. That on. Cake take how many hours? 2 hours. Cookie take how many hours? 1 hour. That means 2x1 plus 1x2. The amount of time used for baking cake and the amount of time used for baking cookie must not exceed how much? 8 hours. How to get the total time consumed for baking cake per unit it is consuming 2 hours into number of units. You will get the total amount of time you consumed for baking total cakes. So that is 2 hours per cake into number of units. So you don't know number of units. We already assumed it as x1. Next, 1 hour for each cookie. To bake each cookie, it is taking how much? 1 hour. Into number of units, you will get the total number of hours you consumed for baking cookies. You don't know number of units of cookies, that's why we take it as x2. So 2x1 plus 1x2 must be less than or equals to 8 hours. Next, total. How many kgs of flour we have? 10 kgs. So you can use how much amount of flour you want for baking cake and cookies, but it must be less than or equals to 10 kgs. Now, how to get the total amount of flour used for baking this particular cake? Cake it take 2 kgs, for cookie it take 3 kgs. Here something is missing. We are assuming it as for making one cake it is taking 2 kgs of flour, and for making one cookie it is taking 3 kgs of flour. Now for one cake it is how much? 2 kgs into number of cakes. We don't know, we are taking it as x1 plus for making one cookie it is taking 3 kgs into number of cookies, that is x2. We don't know the number of units of cakes and cookies, that's why we are taking it as x1 and x2. This should be less than or equals to 10 kgs. So we already done with our constraints. First we did objective function. Next subjective constraints. These are the constraints. Last one is which one it is? Non-negative function, that is x1 comma x2 less than or equals to 0. Sorry, greater than or equals to 0. That means your production must be more than or equals to 0. Your production will not goes to negative. Will you do -1 cakes? Will you make -1 cookies? No, na. You can produce 0 units or 1 or 2 units, but you can't produce -1 units, -2 units. Yes or no? My niece, my sister daughter, she drew one elephant yesterday. She came to me and mama, she said, mama, how is it? First of all, what is it? It is not looking like elephant. I asked her, first of all, what is it? She said, elephant. No, it is not elephant. It is rat. She started crying. My sister came and asked me, how small she is, why you are scaring her? I said, I am not scaring. The truth is scaring her. Look at here. I shown her her drawing. And she said, what wrong with that particular drawing? How cute that rat is. That's what I said, nah. She started again crying. So always truth is scary. Slack variables. Which one? Slack variables. When the constant is less than or equals to, we add an extra variable to make it an equation. Will you solve any equation like this? 2x1 plus 1x2 less than or equals to 10. Will you solve this particular equation? No one will solve. Why? Because here the term is not constant. Here it is variable, less than or equals to. Here is the constant is there, that is less than. How much less than? 1 is less than 10, 2 is less than 10, 3 is also less than 10. Which figure you will take? For that purpose, to make this symbol equal, you will use slack variable s1. Then it will become 2x1 plus 1x2 plus s1 is equals to 10. We removed less than symbol and we added s1. The amount of less than is equals to s1. Okay, to make it a good equation, to make it a solvable equation, we added s1 and we removed less than symbol. What is surplus variable? When the constant is greater than or equals to, we subtract a variable to make it equation. For example, same equation 2x1 plus 1x2 greater than or equals to 10. Now this equation is greater than this one 10. Now 11 is greater than 10, 100 is also greater than 10, 1 lakh is also greater than 10. Then how much the greater than is? The value of greater than is how much? For that we take s1. So we will subtract that particular surplus variable. How much amount of surplus is there now? The greater than part is there now. We will subtract it from this particular equation. Then the equation will come like this: 2x1 plus 1x2 minus s1 is equals to 10. To remove less than and greater than symbols, we use slack variable and surplus variable. If it is a slack variable, we use plus symbol. If it is a surplus variable, we will minus it. Surplus means the amount is already high, we need to deduct it. If it is slack, that means the amount is already short, we need to add it. We need to add surplus slack variable, we need to deduct surplus variable. If greater than symbol is there, use minus. If less than symbol is there, use plus. Did you understand? Am I clear? Very good. Example: you run a juice stall. After completing CMA, we decided to start one juice center. Mango juice profit is 30. Need two lemons and 1 glass. Orange juice profit is 20. Need 1 lemon and 2 glasses. You have 100 lemons and 120 glasses. Just read the problem as it is. Don't dig into the problem. For mango juice, why lemons are you? How I know? I am not running any juice center now. I don't know. For orange juice, it requires 1 lemon and 2 glasses. What is our objective? To maximize profit. How to maximize profit? Maximize the profit of juice center. That is max Z. Am I right? So how to get the profit of juice center? Profit for mango, profit from orange. So how many glasses of, or how many mangoes, how many glasses of mangoes you will sell, you will get the profit. That is, let units of mango is equals to x1, units of orange juice x2. That means how many units of mango juice you will sell is taken as x1. How many units of orange juice you will sell is taken as x2. Now, for each order you will get how much? 30 rupees. That means for each unit you will get how much? 30 rupees. 30 into number of units you don't know. We take it as x1 plus. For orange it is 20 into x2. This is objective function. Subject to constraints. There is some constraints is there. What is that? We have only 100 lemons and 120 glasses. Now you can use how many amount of lemons you want for mango juice and orange juice, but it should be less than or equals to 100. It won't exceed how many? 100 lemons. Now how to get the amount of lemons consumed for mango juice? For each mango juice you want how many? 2 lemons. So total number of lemons consumed for mango juice is equals to 2 into x1. Why? Number of units of mango juice you don't know. That's why we take it as x1 into 2. Next 1 x2. Sorry. That's for orange juice you use how many lemons? 1 lemon. So total number of lemons used for orange juice is how to get it? 1 into number of units. You don't know the number of units of orange juice. That's why we take it as x2. So 1 x2 less than or equals to 100. Next 1 x1. That means for mango juice how many glasses needed? 1 glass. Into number of glasses used for mango juice, we don't know number of units. That's why 1 glass into number of units, we will get the total number of mango juice. So we don't know the number of units of mango juice. That's why we take it as x1. Next plus 2 x2. So total glasses we have how many? 120 less than or equals to 120. Am I clear? Next last one is non-negative function. That means our production or our juices will not go into negative figures. We won't make -1 mango juice. We won't make -2 orange juices. If you want to make, you will make the mango juice or orange juice, that is 1 or 2. If you don't want to make, you won't make any mango or orange juice, that is 0. So x1 comma x2 greater than or equals to 0. That means your production must be always in 0 or positive figures. Your production will not go into negative figures. Am I clear? Any doubts? No doubts. Very good. A firm manufactures 3 types of products A, B, C. The profit on unit of type A, B, C are 3 to 4 respectively. That means for A product profit is 3 rupees, for B product profit is 2 rupees, for C product it is 4 rupees. A firm has 2 machines and below is the required processing time. Firm has how many machines? 2 machines, G and H. Using G and H, you are producing A, B, C. A require 4 minutes of G and B require 3 minutes of G, C require 5 minutes of G. A require 3 minutes of H, B require 2 minutes of H, C require 4 minutes of H. The total minutes available for G mission is 2000 minutes and total minutes available for H mission is 2500 minutes. The firm should manufacture must and should 100 units of A, 200 units of B and 500 units of C. Now first what we need to do is first to construct the table for easy solving of LP problem. So how many products? A, B, C. Now, what are the missions? G and H. A require how many minutes? 4. B require 3, 5. 3, 2, 4. And what is the profit? If you produce product A, you will get a profit of 3 rupees, 2 rupees, 4 rupees. And what is the total minutes available? 2000 and 2500. That's it now. Now, what is our objective? Here data given as profits. That means our objective is to maximize the profit. What is the maximization function? Max Z. So max Z. That means we are maximizing the company profit. So how to maximize company profit? How to get company profit? A profit, B profit plus C profit. Per unit is 3 rupees and we don't know the number of units. It is taken as x1. Let number of units of A is x1 plus 2x2. Number of units of B is x2 plus 4x3. Number of units of C is x3. Subject to constraints. Subject to constraints. What is the first constraint? So we have only 2000 minutes of G. G mission is available for how many minutes? 2000 minutes. You can't use the G mission for more than 2000 minutes. So for A, how many minutes A product is consumed? How many minutes of G? That is per unit it is 4 minutes into number of units, that is 4x1 plus how many minutes consumed by B product from G mission? It is 3 minutes per unit into number of units you don't know, that is 3x2 plus 5x3. That means amount of consumption by A plus amount of consumption by B plus amount of minutes consumption by C must be less than or equals to 2000. Am I clear? Next, 3x1 plus 2x2 plus 4x3 less than or equals to 2500. So this is the constant for G. This is the constant for H. That means H mission is available for only 2500 minutes. The amount of minutes consumed by A, B, C must be less than or equal to 2500 minutes. Now, after here the firm must manufacture 100 units of A. That means you must and should manufacture how many units? 100 units of A. Now we take it as the units of A is x1. That means x1 must be greater than or equals to 100. We taken number of units of A is x1 na. Now the x1 must be less than greater than or equals to 100. x1 greater than or equals to 100. Next, x2 greater than or equals to 200. x3 greater than or equals to 50. The firm must manufacture 100, 200, 50 units of A, B, C. That means you must and should produce 100 units of A. We already taken units of A as x1. We already taken units of B as x2. Already we taken units of C as x3. So x1 must be greater than or equals to 100. x2 must be greater than or equals to 200, x3 must be greater than or equals to 500. Last one is non-negative function, that is x1 comma x2 comma x3 greater than or equals to 0. That means your production must be always in positive figures only. You can't produce the units of A, B, C in -1, -2, -3. That means you can't produce any product in negative. Am I clear?